Welcome back to the GoEngineer YouTube channel. Before we get started, make sure you hit that subscribe button if you haven't done so already. Alright, we'll go ahead and get started. For those of you in attendance, thank you for your time and for joining us. Today's topic will be SOLIDWORKS Flow Simulation. My name is Enrique Garcia, and I'm an applications engineer here at GoEngineer, specializing in our simulation products. Today we'll be talking about some of the more important tips and tricks that will help us be more efficient at using SOLIDWORKS Flow Simulation. Some of these tips are foundational, and some of them are just items that are handy to use or things that I've discovered over the years while using Flow Simulation. So here's the agenda of topics that we'll be covering today. Also, we are planning on recording and sharing this webinar with everyone on our YouTube channel at some point after our broadcast. So if you couldn't attend the full session or something comes up, you'll be able to watch the full presentation at your convenience at a later time. Also, if you have questions during the presentation, please feel free to use the question UI in our interface to post any questions. And if everything goes smoothly, I'll be able to see them and try to answer them as I go along. We will also have some dedicated time after the presentation to answer any related questions as well. Alright, with that being said, let's go ahead and get started. The first step I do mention a lot, but it's very important. I want to talk to you guys about the idea of pre-processing your model. This usually means simplifying your model for the use in a simulation. If you're building a model that has all its small fasteners or tiny details into a project, this could really increase your calculation time and the amount of calculation resources required to run the project. In order to reduce this as much as possible, we address our models in about 3 ways. First, we have the attempt at defeaturing our models as much as possible. There are 2 approaches to doing this. First, we can create a separate configuration and suppress all features related to details on your model of features, or features that you think, as a designer, will not impact the flow or thermal performance of your model in the simulation. The second approach is to do a SOLIDWORKS pack and go of the original model, and then modify or defeature that particular model. The second way we can address a model is by idealization. Idealization is the process of replacing a more complex component or portion of your model with a simplified one. This can be done with the replace component command in SOLIDWORKS, or it can be done by flow simulation, such as by using the fan definition or porous media definition in the project setup instead of the actual model geometry. The third way we can address a model before starting a flow project is by doing any model cleanup or repairs. Errors such as translation errors, if you are importing your model from one modeling software kernel to another, may need to be cleaned up using import diagnostics tools, or at least checked out using the check entity tool in SOLIDWORKS. Good old-fashioned surfacing and patching of your model may be required to fix any found errors. We also have a check geometry tool specific to flow simulation. We'll actually show that tool in a few minutes. Overall, if you fail to at least review your model for any of these items before starting your first project on your design, this can result in significant increased calculation time, problems with calculating internal volumes, meshing troubles, and just a higher probability of getting flow simulation errors and warnings in general. Let's talk about the next tip. So once a model or design is prepared for analysis, it's important that we decide what kind of analysis type we're going to choose. In flow simulation, we can choose 2 calculation approaches in an attempt at keeping the calculation time as slow and efficient as possible. We can choose between an internal analysis or an external analysis. If we're only concerned about the flow characteristics of an internal structure of your model, it's more efficient to use the internal analysis option for that situation. With this option, the project will look for fully encapsulated volumes within the computational domain, and will implement the simulation of fluid flow using those volumes only. All other fluid volumes not bound by the geometry will be neglected, resulting in a shorter calculation time. A tip about enclosing these internal volumes is to look out for zero boundary thickness geometry conditions in your CAD model. Examples can be seen here to the right of this slide. Ensure that you're enclosing your volumes with solid bodies that are coinciding face to face or have a bit of volume interference. Any coinciding entities that involve edges or points will potentially be seen as an opening since we're operating within the SOLIDWORKS ecosystem. If you require the calculation of fluid flow around your model, it's best to choose the external analysis type for this. Examples of this can be fluid flowing over an aircraft or building. There are no special geometric considerations here. We're only bounded by the size of our computational domain of our project for these external analyses types. With external analysis, you can also analyze connecting volumes that are both internal and externally surrounding the model geometry. When working with an external analysis, it's a good practice to ensure that your computational domain is not too close to your actual model geometry, causing it to interfere with the surrounding flow fields that can interact with your model. Keep the boundaries of your computational domain at a good distance from your model geometry at first, at least to see how much you should shrink your computational domain for future runs of your project. Speaking of tips about working with your flow project, something related, and it's a foundational suggestion, is that it's important on how you should approach setting up your project, especially if this is your very first time that you're setting up a project with a new model. When I teach the flow simulation course here at GoEngineer, I always tell my students to start their project setups as simply as possible, maybe even oversimplifying them at first. If it's an internal analysis, define your inlets, outlets, and establish some engineering goals. Then maybe add some boundary conditions to represent fans or other more complex geometry. The goal here is to get a simple starting and working project that can then evolve into the project that you want to end up with. Once you have a good starting project that runs with no warnings or errors and gives you some ballpark values, we can then begin to replace the oversimplified conditions in your project with more advanced flow definitions or conditions, something like perforated plates, porous media or fans, etc. Also, we can modify existing boundary conditions to make them more accurate, like turning on the option fully developed flow, for example, under the flow parameters shown here on the screen on the right-hand side, or introduce maybe some custom defining items to your project from the engineering database, things like maybe custom liquids, gases, or thermal resistances. Overall, this approach will usually help avoid any complex or time-consuming troubleshooting in general, since you'll be setting up your project in sub-steps. Another tip I'd like to review with you all is the use of the check geometry functionality in flow simulation. Since flow simulation divides our geometry into both solid and fluid regions, it's a good idea to first test for these regions before beginning any flow project. This way, if we notice that a region was not detected properly, we can fix any geometry issues in CAD early on before starting our projects, and prevent us from having to go back and fix geometry issues later. For those of you that have not worked with the check geometry tool, I have a quick example to show for you. So let me open up SOLIDWORKS here, and we have just a simple section of an exhaust system or piping of some sort. And we're going to be doing an internal analysis on this if I were to run a project. So the idea is we have some lids that have plugged up the inlet and the outlet portions of this little exhaust or pipe system that we're going to be analyzing. And we want to make sure that we have a proper internal fluid to be able to analyze. So I'm going to go into the Flow Simulation tab under the Command Manager, and I'm going to click Check Geometry. Under the Check Geometry Property Manager, we have the participating solid bodies. And under Analysis Type, since we haven't specified any fluid projects yet, we can specify the type that we're going to be using, which is going to be internal. And then we'll click the Check button. Under the results here, we're going to be paying attention to the fluid volume here. So we actually have a fluid volume of the model. Now if we had a 0 result for the fluid volume, this would tell us that we have some sort of leak or some continuity between the internal volume and the external volume of this pipe. At that point, you would want to go into the CAD model and maybe adjust your lids or whatever geometry that you're dealing with to try to close those particular leaks if you have more than one. Something we can use, which we'll cover here in the next example actually, is a leak tracker tool that can help you diagnose where those leaks could potentially be. Also with this Check Geometry tool, if I scroll down, we can click the Show Fluid Volume function, and this will give us a nice visualization of what that fluid volume that will be analyzed in a flow will actually look like. So that's the Check Geometry tool here in Flow Simulation. Another tool that's related and is popular to use before starting a flow project is leak tracking. So let's say that you checked your model for an internal fluid volume, but you still can't identify the desired fluid region using that geometry checker tool we just saw earlier. This means that there's a leak somewhere in your design, although it may not be easily identified. This utility allows you to locate these particular leaks. To use a leak tracking utility, you simply select a face that is supposed to belong to the internal cavity, and for the second selection box, you select a face that is on the outside of the cavity. If there is a leak, leak tracking will draw a path from the first selection face to the second. we can then follow a path that's generated to locate our leak location. Let's go back to SOLIDWORKS, and I have another example I want to show you for this particular tool. So here we have a leak or a collator or a header of some sort, and we have some lids that are plugging out the inlet and the different outlets here of our model. Now, I purposely went into this particular lid and I've moved it to the side to create a leak there, of an opening between the internal and external volumes of this design. Now when I go over to the check geometry tool, and since this particular model has a project already, it knows this is going to be an internal analysis, so it's going to go in and do a check. And it's going to let me know that we have a 0 unit volume for this model, indicating that there is a leak somewhere. Now we can click on the shortcut to the Open Leak Tracking tool here, or if I close out of that, I can go under the Tools menu under the Flow Simulation tab in the Command Manager, and I can click the dedicated leak tracking utility from this particular line item. So this will open up the same interface. Either way, however you decide to activate it, this will open up the leak tracking utility or functionality. Now the idea here is you choose an internal face for the first box and an external face of the model for the second box. So I can go in here and I can pick that internal face. So to do that, maybe I want to do a section view perhaps, just to use some standard SOLIDWORKS functionality, just to temporarily section the model up. So I'm going to choose the internal face there of the inlet lid. And for the second box, I'm going to go in and choose maybe the, I'll just choose this face here. I know that's definitely on the outside of the model. And then I'll click Find Connection. Now at that point, SOLIDWORKS will analyze and will suggest a path from both surfaces. And it's up to us to go in and trace that path until we find where the model changes from an inlet volume or internal volume to an outside volume. And for us, it's along the area where I purposely moved that lid about here. Again, this is going to give you some suggestions using a path, so it's up to us to look at the geometry and make our own conclusions as to what to do to fix the geometry. So that's how we identify leaks in SOLIDWORKS Flow Simulation with the utility. The next step I want to go over is how to manage the engineering database. The engineering database is a database used specifically for flow simulation, for unit systems, physical properties of fluids and solids, and characteristics of assignable definitions to your models for any wide variety of engineering devices and materials. The database is made up of predefined data that is read-only and cannot be modified, and user-defined data that can be updated and managed. The data shown in your engineering databases are taken from 2 separate XML files named chembase XML for the predefined data and chembase user2 XML for the user-defined data. Let's say that you've expanded your user-defined categories on your database with many custom fluid mediums and fan definitions, and you'd like to share your user-defined portion of your database with your colleagues, just as an example. You can do this by locating your user-defined database XML file named, again, chembase user2 XML, and sharing that particular XML file. The default location for this is going to be outlined here in red on the screen for you. So once your colleagues have your user-defined XML file, they can either replace the file in their same directory, or they can repoint their own flow simulation to the new XML file. They can repoint the flow install by opening the Flow Simulation Options menu in SOLIDWORKS on their computers, and under the General Options category, they can then just browse to locate the new XML under the title here named User-Defined Database Location, which again is outlined here in red on my slide here. You can also try sharing the same user-defined XML file to maybe, let's say like a shared location on your network so that everyone can point to that and use the same XML file. This might be convenient only if your participating computers are to remain just connected permanently to that network you're using. Lastly, if you have your own custom entries in your own database and you don't want to just replace the custom entries with another set, you can merge additional user-defined XML files with your own by simply opening up that engineering database on your own install, and then from that pop-up window you can click the File Import function you see here. You can merge additional user-defined XML files with your own by simply opening up the engineering database on your own install. You'll just click the File menu and then click Import. you'll browse to that desired chem-based user2 XML file and just click the Open button. Flow Simulation will then organize the new entries under all applicable user-defined folders in your engineering database for you. You can also continue to manage your user-defined folder just by right-clicking on them in the database, and you can create additional subfolders, rename entries, cut, copy, or paste, and also delete undesired entries. The last tip before we get into some tricks that I'm going to be covering is the use of the transparency tool in Flow Simulation. Nested deep within the submenus of the Flow Simulation menu system, we have an option called Transparency. This is a Flow Simulation specific model transparency capability that will allow you to specify the transparency amount globally for all model components that are a part of the active Flow Simulation project. This is very useful, especially when you're interrogating result plots for internal analyses. I want to make sure that you show the internal volumes with flow trajectories, surface plots, or fluid flow plots. This is pretty useful, especially when you're interrogating result plots for internal analyses. I want to make sure that you show the internal volumes with flow trajectories, surface plots, or fluid flow plots. By default, this is not readily handy when you install the software. So you can actually access the transparency tool from the main SOLIDWORKS Tools menu under Flow Simulation, Results, Display, and then select Transparency. It's kind of hidden deep in that menu system. If you're going to use this tool a lot, I would recommend that you customize your Flow Simulation tab on the Command Manager and add that transparency tool to your toolbar. I'll show you guys how to do that here in a moment. Also, when I'm showing results, I personally use a transparency somewhere between 80 and 90%. This seems to give me a good balance between showing results and still showing important portions of my model geometry. One thing to take account, however, if you'll be using the transparency tool, is that it does override all your display state transparency settings for your SOLIDWORKS model, so just kind of be mindful of that. Let's go back into SOLIDWORKS and let me show you where the transparency tool is located and how to customize your Flow Simulation toolbar in the Command Manager. So if I want to modify this particular model, let me just get rid of that for now. I'll go up to the Tools menu, Flow Simulation, Results, Display, and then Transparency. So I can make this a little less transparent there, click OK. It'll update my global transparency setting there for SOLIDWORKS. Now if I wanted to have this particular functionality be a part of my Flow Simulation tab in the Command Manager, I would go under the Tools menu now and then go down to Customize. Now not Customize menu, make sure you go to Customize here, and this will open up your Customize little pop-up window. We'll come on down over to Commands, and we'll go down to our Flow Simulation commands, and we're looking for, and we're going to click on Flow Simulation Result Display Group. Once you've clicked on that particular category or list there on the left, the toolbar list, we'll go ahead and click and locate the transparency functionality, and all we're going to do is click and drag that with our window open over to our desired location on the Property Manager, or excuse me, on the Command Manager. Once that's open, then you can right-click and you can show text or maybe begin a new group there if you would like. Click OK, and now you have that functionality as a shortcut. Next, let's show some neat tricks that I've discovered over the years while working with Flow Simulation. Since Flow Simulation functions inside the SOLIDWORKS ecosystem, we can take advantage of SOLIDWORKS environments. More specifically, the lighting settings under the multicolored sphere tab called the Display Manager. We can use this so we can fine-tune the visibility of our result plots. On this slide, I'm showing an exaggeration of what could happen due to my ambient SOLIDWORKS lighting. Depending on some of the SOLIDWORKS lighting environments, the directional and ambient lights from the model environment may not be optimal for showing Flow Simulation results. The colors of the plot could appear darker or muted as compared to the bright color bar. If this is the case, we can edit the lighting settings under Scene, Lights, and Cameras section of the Display Manager as shown on the slide here. We can go in and then modify the ambient slider to something more realistic to what the color bar displays. The next item seems more like a trick if you're used to creating all your lids for your Flow project from scratch. This is the Create Lids utility in Flow Simulation. If you're a Flow Simulation veteran, you've probably already used this tool before. Create lids will automate the creation of lids in your models, whether you're in an assembly or a part file. This tool is especially useful if you plan on creating an internal analysis for your project. With the tool open, you simply select a planar surface, and it will generate a lid in the shape of any voids that touch the specified surface, ensuring that there will be no leaks in the region. If the model you're working on is an assembly, SOLIDWORKS will generate separate virtual components for each lid created. If you're working on a part file, it will create separate solid bodies to manage. One last thing to take into account is that if the model or openings are changed in the CAD model geometry in any way, you will have to manually correct any lids generated using this Create Lids tool, since there are no parametric relations that are added when you change the geometry. Oh, also, this tool is not supported for openings that are non-planar, things or geometry such as cylindrical surfaces or openings along compounded surfaces, for example. Non-planar surfaces, for those, you'll just have to go on and create lids using our regular SOLIDWORKS CAD tools. Let me go back to SOLIDWORKS here. I want to show you just a quick example on how to use the Create Lids tool functionality. So to create lids here, we're going to be using this particular electronics box, and we have quite a bit of openings on this thing, but the goal is to do an internal analysis for this project at some point, so we're going to need to make the internal volume airtight. So I'm going to use the Create Lids utility for this. I'm going to go up to the Tools menu, and under the menu pull down, I'm going to click on Create Lids. Now under the Create Lids functionality, it just says select planar faces the openings belong to, and I can click on any particular faces. The software again will detect where those voids are and will generate a lid, and the lid is actually interfering quite a bit to ensure we have a nice airtight lid that's being created. Now you can do that with simple surfaces, or you can do that with a surface with more than one void or opening, like we have here with some slots and a little trapezoidal lid. When I click on that particular face, it will automatically generate that trapezoidal shaped lid and 8 slot shaped lids. And then we'll do one here for the circular opening for the fan. Once you're done, click the green check mark for OK. And since this is an assembly file, we're going to be generating virtual components in our simulation design tree to manage those particular lids. Now again, these lids are not intelligent in any way. They're just dummy little imported bodies, so they will need to be updated if you do need to change the geometry of these voids or these openings for your model in the future. Next, let's talk about some native SOLIDWORKS tools that can also be used while setting up a flow simulation project. The first tool I want to touch on is called Select Other. Select Other allows SOLIDWORKS users to on-the-fly dig into or expose the different layers of their model in the graphics area, wherever the pointer was located, to expose or select interior surfaces while using various commands in both SOLIDWORKS and for us for flow simulation. For example, when you're in the middle of adding an inner surface for a boundary condition or some other constraint for a selection box, you can right-click on the outer surface for your model and choose Select Other and continue to right-click until the desired surface is exposed enough to select it. This can be more convenient of a workflow than having to hide and then show certain components, or is easier than creating exploded views for all your models, depending on what you're doing with your model. Let's go back to SOLIDWORKS to show a quick example of this. Alright, so let me go ahead and maybe let me make this a little less transparent. And the idea here is maybe I am adding another inlet volume, or maybe I'm editing this volume, and you can see that I have an internal face, the internal face of this lid selected. I'm going to deselect it, and I'm going to reselect it using this new Select Other functionality I just talked about. So the idea here is, with the Property Manager open with a blue selection box, you'll go to your graphics area, and you do a right-click over an exterior surface of your choosing. In your right-click menu, you're going to click Select Other. Now that will temporarily hide that particular face you just right-clicked over to expose any interior surfaces or faces. Now the idea here is I'm going to right-click once again on that particular surface. This is the inner surface of this particular portion of the model. When I right-click again, it's going to hide that. And now I have access to the internal surface. But the idea here is I can continue to right-click on things to hide any portions of our models and continue to dig into our models until we expose the desired surface. So for me, I'm going to select this internal surface of the lid and click OK to finish that. So that's the Select Other functionality. The other SOLIDWORKS native tool I want to share with you all is called Selection Sets. Selection Sets allows you to save or package a group of points, edges, faces, solid bodies, or any reference geometry for reuse without having to select all the items over and over again. This works out pretty great, especially if your model is especially detailed, where there may be a lot of faces to select repeatedly for assigning different flow conditions. Packaging or pre-selecting all selection entities ahead of time will eliminate much of that extra or redundant clicking that we had to do before. The worst is when you're close to finishing selecting all the small faces in a command and you mess something up and have to start over again. Just such a pain in the butt. So let me show you how this functionality works here with an example in SOLIDWORKS Flow Simulation. So we'll just use this existing collator model we were working earlier, and if I go back to the SOLIDWORKS design tree, I'm just going to have this shown here, and while that's showing, I'm going to hold my control button down and select a couple of different unrelated faces, just just random faces. So I'll select these faces here for my example. Now with those faces selected, I'm going to do a right click on my mouse. I'm going to hover my mouse to my item for Save Selection and click New Selection Set. Once I save that selection set, we're going to get a new dedicated selection sets folder in the SOLIDWORKS design tree, and I can go in and I can access those particular faces. I can click on them to highlight them. I can see which faces are participating or saved in the selection set, and I can right click and remove the selection set just to kind of manage that later on. So I'm going to keep it in there, and while I'm in there, I can now go over to my flow simulation analysis. I can maybe do another boundary condition, and instead of going in and selecting all those faces over again and over and over again, I can click on the blue box and locate the selection set under the SOLIDWORKS design tree, under the selection sets folder. And again, this will just populate your selection box. You'll click OK, and you'll be done with it. So that's how you use the selection sets functionality in Flow Simulation, and this is a SOLIDWORKS function, so it can be used with any SOLIDWORKS property manager. The last trick I want to show you for this presentation, I actually found this out as a joke, thinking it actually wasn't going to work. I was pleasantly surprised, as you can tell here. I was actually pleasantly surprised that it did. The trick here is that we can have Flow Simulation result plots on or animating and create a SOLIDWORKS walkthrough. Let me click play on this slide here to show you this video I created. So there's a quick video here of a simple electronics box with a fan, and it's introducing cool air into the computational domain. So I'm panning here, and we can see that the air starts to heat up as it interacts with the heat sink structure. And later on here, we can more easily spot an area of recirculation at the end of the video. It's right there. Using these SOLIDWORKS walkthroughs is just a different way to experience your model and your flow simulation results. It may help you find issues or behaviors with your results that may have been a little more difficult to detect otherwise. And this actually would be perfect to explore or showcase for maybe HVAC projects or any larger models running flow simulation. Let's go back to SOLIDWORKS one last time and let me show you how to recreate this with SOLIDWORKS walkthroughs. So here we have an already set up electronics box where we have a fan, and the fan is importing cooler air into the computational domain, and it's going to be recirculated into the actual interior of the electronics box. So I've already ran the project, so I'm going to activate and load some results. And I'm going to show and animate my flow trajectories. So after that, we're going to go over to our display manager in SOLIDWORKS. We're going to make sure we're under scene lights and cameras, and we're going to go in and under walkthrough. You can see that I have already created that walkthrough that I made the video with. I'll make one from scratch here to show you how it's done. So I'm going to right click on the walkthrough folder and select Add Walkthrough. Now under viewport settings, we've automatically selected the top plane, but we can just as easily done maybe the select other tool, and we could have selected that top of the PCB, which is going to be the same here in this case. At that point, we can select our starting height for our model. In this case, I'm going to choose something like, let's just do 12 millimeters, and click Start Walkthrough. Here we get some quick instructions on how to navigate our walkthrough functionality. So I'm going to click OK and just kind of follow along here. And we can see that we can kind of recreate what we were doing earlier where I was at the top, maybe looking downward and maybe doing a pan function, taking a look at our heat sink, maybe getting closer to the heat sink, and maybe finding that area of recirculation on the corner there of the model structure. So here we have the record functionality as well, and that's how I did the recording for the slide you saw earlier. I'm going to click the X to close the walkthrough, and you could save that walkthrough as well. Alright, so that was the last trick I had for this webinar. Before we end with any questions, I just wanted to promote our dedicated GoEngineer YouTube channel. We post videos here very regularly, and we invite you all to subscribe and stay up to date with our latest uploads. We also will be posting this particular webinar up here in case you wanted to re-watch it or missed any portion of the presentation today. We have a wide range of topics that can be covered, including many other simulation videos, so definitely feel free to stop in and search our extensive archives. We also produce a blog on our website that's very active with many tips and articles with useful information regarding SOLIDWORKS and many other technical topics. We also showcase fun projects here from time to time. Our engineers have been working on things related to 3D printing and 3D scanning. So again, there's a nice variety of knowledge value that can be found there. All right, with that being said, we'll leave this webinar open and we'll help answer any other questions, related questions we didn't get to. If you're heading out, thank you again for dropping by. And if you're heading out, thank you again for dropping by, and keep an eye out for any newsletters or any new presentations or new uploads on our YouTube channel. All right, let's go ahead and take a look at any questions. Thanks for watching. If you enjoyed this webinar, please subscribe and leave us a comment below if you have a topic you'd like us to cover in a future video. Visit our website, GoEngineer.com, for access to professional training, upcoming events, and more from your #1 online technical resource. Bye for now. Take care.